Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. We're going to be continuing looking at designing a batch still using AspenPlus BatchSep. So we have this set up, and we were in the midst of specifying this, and I realized that what I had done wrong is that we were actually starting out with total reflux until we get the system to steady state instead of an initial charge. So that now has everything ready to go to our operating steps. So this is where we're going to tell Aspen how we wish to operate this still. Because we are changing things over time, this is going to be where we say, okay, first I'm going to put material in. I'm going to change the reflux ratio to 3. Whatever it is we're going to do, if we're going to change out our distillation receivers, etc. Okay, so we have 2 operating steps. First, we're going to be operating at total reflux until we reach steady state. We're going to do this by allowing 30 minutes for that to happen and say that's probably adequate. And then we'll switch to a reflux ratio of 3 and begin accumulating our distillate product until we reach a mole fraction of material entering the distillate that's less than 0.1 mole fraction benzene. So to do this, we want to say that we're going to add a new step here, okay? And this has changed a little bit from what it looks like in the older version, but the steps are essentially the same. So what we're going to have here is we're going to identify the location and the length of time and what variables we're going to be tracking during this. Now in this case, we're going to be doing the reflux ratio is infinite. So the location is going to be at the reflux splitter. And we're going to be looking at the reflux ratio. The value, we want to say infinity, that's not possible. So just put in a large number, okay? And that's going to be adequate for this. And I want to say how long I'm doing this, and I'm doing it for 30 minutes or half an hour. Okay. All right, so we have operating step 1. And I'm going to rename this just because that's sort of an awkward name. Startup. And now then I want to add my second operating step. So this operating step is going to be changing the reflux ratio. Okay. So we're going to at this start be creating product. So that's why I named it. Okay. Yeah, I went too many characters, but so we'll create a product, my description. Apparently and I want to view this. Okay, so this time I'm going to change the reflux ratio to a value of 3. Okay, and I'm going to stop not based on time, but based on the composition. So in the condenser, I want to be looking at the liquid mole fraction of benzene less than, oh, now I can't remember, 0.1. It's something. Okay, if I got that wrong, it's just a different number. And so this is going to be when it's going to stop. Now notice that it does always give, in case you gave an impossible condition, that it will stop at 24 hours so you don't get into an infinite calculation loop. At this point, the run has now lit. We can click that. And it does take a little while. I think that it surprised me the first time how long it did take to run this simulation. All right, so I didn't make you watch the entire time it ran. You'll notice that as it does it, it kind of shows you where it is in the calculations by changing colors. And we can look at our run status results. Okay, oh, we had errors. Okay, so we had that the startup, the product ran for 0 time. I think I had the wrong composition in there. It shows me profiles over time, what's happening, so I can look at the temperature changes over time. And I can look at what's going on in my various streams as my final product. I do think that I need to go back in and change my compositions here and run it again. Okay, I took a moment to reread the problem statement. I had the 0.1 correct. What I missed was that it's going to start at a higher mole fraction and decrease, so it's approaching from above. And at that point, hit run, and you can come in and look at the results. You can look at it over time. You can look at stream results, what your final products are, etc. So I invite you to play with this. Feel free to try adding other operating steps. What happens if you now change the reflux ratio to something else? Or anything. You can put in many more operating steps than just a simple 2. But this gives you a brief idea of how the batch operations work without us having to go in and actually enter the differential equation models. So thank you very much for your time.